Today we are going to discuss JEE Main September 6 shift to physics paper. So let us see first question. A circuit to verify Ohm's law uses ammeter and voltmeter in series or parallel connected correctly to the resistor in the circuit. So which of the following is correct? So now this is a resistor. This resistor is connected to the battery. This resistor is connected to the battery. Always ammeter is connected series in the circuit, and voltmeter is always connected. Voltmeter is always connected in parallel to the resistor. So this is the correct connection of voltmeter and ammeter. So our option is option 3. Ammeter is always connected in series and voltmeter in parallel. Current measuring instruments always connected in series. So let us discuss another question. Consider the force F on a charge Q due to a uniformly charged spherical shell of radius R carrying a charge Q distributed uniformly over it. Which one of the following statement is true for F? If Q is placed at a distance R from the center of the shell. So this is the problem. This is a spherical shell. This is a spherical shell. So charge is distributed uniformly on a spherical shell. Now the radius of the spherical shell is capital R, and charge small q lies at a distance smaller from the center of the spherical shell, outside the shell. Then what is the force? Which of the following equation is correct for the force equation? We know that inside the spherical shell there is no charge. So inside the spherical shell electric field intensity is 0, hence force is 0 inside shell. A is equal 0, F is equal 0. So outside the spherical shell at a distance r from the center of the spherical shell, force acting on a charge small q, F is equal to EQ. So F is equal to, E means what we write here, 1 by 4 pi epsilon naught q by small r square into q. So our force equation is F is equal to 1 by 4 pi epsilon naught capital Q into small q divided by r square for small r is greater than r, capital R. Small r is greater than capital R. So our option is option 4. When a car is at rest, its driver sees raindrops falling on it vertically. When driving the car with a speed v, he sees the raindrops are coming at an angle 60 degrees from the horizontal. On further increasing the speed of the car to 1 plus beta into v, this angle changes to 45 degrees. The value of beta is close to. So here the case 1, when car is at rest, the raindrops are falling vertically, falling on it vertically. When the car is at rest, right. Now in case 2, when the driving the car with a speed v, when the driving the car with a speed v, he sees the raindrops are falling at an angle 60 degrees from the horizontal. That means velocity of rain with respect to man is 60 degrees with the horizontal. 60 degrees with the horizontal. So here by using parallelogram law, we write here tan 60 is equal to VR by V. So what we write here, VR is equal to root 3 into V, equation 1. So case 3, when the car increases speed to 1 plus beta into V, 1 plus beta into V, the rain is falling at an angle 45 degrees with the horizontal. The rain is falling at an angle 45 degrees with the horizontal. Velocity of rain with respect to man. So here tan 45 is equal to, we write VR by 1 plus beta into V. So VR is equal to 1 plus beta into V. Equation, this is 2. Now from equation 1, VR is equal to root 3 into V. So root 3 into V is equal to 1 plus beta into V, V cancel. 1 plus beta is equal to root 3, beta is equal to 1.732 minus 1. So beta is equal to 0.732. So this is the value of beta. So our answer is beta is equal to 0.732. This is the answer. So let us discuss another question. A fluid is flowing through a horizontal pipe of a varying cross section with a speed v meter per second at a point where the pressure is P Pascal. At another point where pressure is P by 2 Pascal, its speed is v meter per second, capital V meter per second. If the density of the fluid is rho kilogram meter per second cube and the flow is streamlined, then capital V is equal to. So here there is the horizontal tube. This is a horizontal tube. So in this horizontal tube, at one point fluid is entering into the tube with a small v meter per second. At this end the pressure is P Pascal, and at another point the fluid is leaving from that end with velocity capital V with at the pressure P by 2 Pascal. Density of the fluid is rho kilogram meter per second cube and the flow is streamlined. Then capital V is equal. Simply we use Bernoulli's theorem. V1 plus of rho V square plus rho GH is equal to P2 plus of rho capital V square plus this is H1 and rho GH2. Since this pipe is a horizontal pipe, this pipe is a horizontal pipe. So this end both are at same height. So here H1 is equal to H2. So we write this formula P1 plus of rho small v square is equal to P2 plus of rho capital V square. So here we substitute P1 is equal to P plus of rho V square is equal to P by 2 plus of rho capital V square. Now here P minus P by 2 is equal to of rho V square minus of rho V square, small V square. This is equal to here P by 2 is equal to of rho into what we write here capital V square minus small v square. So here 2 cancel. 2 cancel. So P by rho is equal to capital V square minus small v square. Small v square. Now we want to find out what capital V, the velocity of the fluid at this end. So here we write P by rho plus small v square is equal to capital V square. So here V is equal to capital V is equal to square root of P by rho plus small v square. This is the velocity of the fluid at the second end. This is. So let us see another question. A double convex lens has a power P and the same radius of curvature R of both surfaces. The radius of curvature of a surface of a plano-convex lens made up of the same material with power 1.5 P is. So this is a double convex lens with the equal radii. That means this lens is also called equiconvex lens. Here R1 is equal to plus R, R2 is equal to minus R. So this double convex lens has equal radius. Then we know that 1 by F is equal to n minus 1 into 1 by R1 minus 1 by R2. 1 by F nothing but what? Here power of the lens is equal to n minus 1 into 1 by R plus 1 by R. So P is equal to what we write here? P is equal to here n minus 1 into we write 2 by R. Equation 1. Now the radius of curvature of a surface of a plano-convex lens made up of same material with power 1.5 P is. So another lens, that lens is a plano-convex lens. We want to find out that radius of curvature of a lens. This is assumed as R dash, and here we write 1 by F is equal to n minus 1 into 1 by R1 minus 1 by R2, that is equal to 1 by R dash. Radius of this radius of curvature of this plano-convex lens, and the second one is plane surface. So R2 is equal to infinity. So here R1 is equal to R dash. Now we want to find out what radius of curvature of this plano-convex lens. So here the power of this lens is 1.5 times of power of the first lens into n minus 1 into 1 by R dash. Equation 2. Here 1.5 P is equal to we write n minus 1 into 1 by R dash. Equation, this is 2. What is equation 1 here? P is equal to n minus 1 into 2 by R. This is equation 1. So equation 1 divided by equation 2. What we write here? 1 by 1.5 is equal to 2 by r divided by 1 by r dash. So 2 by 3 is equal to 2 by r into r dash. 2 cancel here. R dash is equal to what we write here, r by 3. So this is the radius of curvature of this plano convex lens. Radius of curvature of this plano convex lens. So our option is, what is our option here? Option 1. So let us discuss another problem. 3 rods of identical cross section and length are made 3 different materials of thermal conductivity K1, K2, K3 respectively. They are joined together at their ends to make a long rod. So they are joined like this. One end of the long rod is maintained at 100 degrees centigrade. Okay. And the other at 0 degree centigrade. If the joints of the rods are 70 degrees centigrade and 20 degrees centigrade from the surface of the rod, so in steady state there is no loss of energy from the surface of the rod. The correct relationship between K1, K2, K3 is. So this is the problem. So these rods are connected end to end, so that here rate of flow of heat is constant. What constant? Rate of flow of heat is constant. That means heat current is constant. Q by T is equal to constant. These rods are connected in series, so that here rate of flow of heat is constant. So we write here K1 A, K1 A 100 minus 70 divided by L is equal to, so for second rod we write here K2 A 70 minus 20 divided by L. All the rods have same area of cross section, same length, is equal to K3 into 20 minus 0 into A divided by L. Rate of flow of heat constant. So what are the common terms in these fractions? A by L common. So K1 into here 30 is equal to K2 into 50, that is equal to K3 into 20. So 3K1 is equal to 5K2 is equal to 2K3. Now we take ratio K1 by K3, 2 by 3. So here we take ratio K2 by K3, 2 by 5. So what is our option here? Option 4. Answer 4 is the correct answer. Let us discuss another question. A student measuring 3 diameters of the pencil of a circular cross section with the help of vernier scale records the following 4 readings. 5 point he records following readings as following: 5.509 millimeter, 5.55 millimeter, 5.45 millimeter, and 5.65 millimeter. The average reading of these 4 readings is 5.5375 millimeter. The standard deviation of the data is 0.07395 millimeter. The average diameter of the pencil should therefore be recorded as, according to rules, significant rules, these measurements has significant numbers 3. Number of significant numbers, figures is 3. So according to significant rules, answer should be in 3 significant digits. So what is the average diameter here? 5.5375. It has 5 significant figures. It should be in 3 significant figures. That means here 7 should be eliminated. So 7 should be eliminated means this is greater than 5. So according to rounding off rules, the preceding digit should be added to 1. That means this is becomes 5.54 plus or minus. Here 3 should be eliminated. This is less than 5. So preceding digit remain as it is, 0.07. So our answer is, so that answer should be in 3 significant figures. So our answer is answer 3. Answer 3. This is the correct answer. So let us discuss a very simple question. In a dilute gas at pressure P, temperature T, the mean time between successive collisions of a molecule varies with T as. Here V average, that means V RMS velocity, V average is directly proportional to temperature. So we know that V RMS is equal to square root of 3R T by M. So average velocity directly proportional to root T. So we know that the mean time, T mean time, the mean time between successive collisions, T mean is equal to, what is mean free path? Mean free path divided by average velocity. So T mean is inversely proportional to root T. T mean is inversely proportional to root T. So what is our option? Option 1. Here V average directly proportional to root T. T mean inversely proportional 1 by root T. So our option is option 1. Option 1. So next question. For a plane electromagnetic wave, the magnetic field at a point x and time t is. So B x comma t is, what we write here, 1.2 into 10 power minus 7 sine 0.5 into 10 to the power of 3x plus 1.5 into 10 to the power of 11 t k cap t. The instantaneous electric field is, this is Tesla. So this is the equation for magnetic field. So we know that here E naught by B naught is equal to C. Maximum amplitude of electric field by maximum amplitude of magnetic field is C. So here E naught is equal to C into B naught. What is C here? 3 into 10 to the power of 8. B naught, what is B naught here? 1.2 into 10 to the power of minus 7. So what we get here? We get 3.6 into 10, that is equal to 36. That is equal to 36. volt per meter. So this is expression for maximum amplitude electric field. So now we are going to write electric field equation. Before that, we also find out the direction of electric field. So here the wave is traveling along negative x direction. You know that here E bar cross B bar is equal to C bar. So here the wave is traveling along negative x direction. So that what we write here, the wave travel along minus I cap direction. That is equal. What is the direction of magnetic field here? K cap. Now we want to find out what is the direction of electric field. So here electric field direction is, if we multiply, if we cross product J cross K, we get I, but we want to get minus I, so that here it should be minus J cap. So that direction of electric field E is equal to, direction of electric field E is equal to 36. We write as it is equation, E naught sin omega t plus kx sin 0.5 into 10 cube x plus 1.5 into 10 to the power of 11t, here minus 11t J volt per meter. So what is our option here? Option 4, that is correct answer. Option 4 is the correct answer. So let us discuss another question. A particle of mass m1 moving with velocity root 3I plus j meter per second collides with another particle of mass m2, which is at rest initially. Let v1 bar and v2 bar be the velocities of the particles A and B after collision respectively. If m1 is equal to 2m2 and after collision v1 bar is equal to I plus root 3j, the angle between v1 bar and v2 bar is. So this is a particle of mass m1 which is moving with the velocity u1. This particle collides another mass m2 which is at rest, u2 is equal to 0. After collision, first body moves with velocity v1, second body moves with velocity v2. So here they gave u1 is equal to root 3I plus j meter per second. So u1 is equal to root 3I plus j, and also they gave m1 is equal to 2m2. v1 is equal to I plus root 3j meter per second. v2 is equal to question mark. In any type of collision, momentum is conserved. So we use here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here m1 is equal to m2, u1 means root 3I plus j plus 0, u2 is equal to 0. Here again m1 2m2 into v1 I plus root 3j plus m2 v2. So both sides m2 cancel. Here 2 root I plus 2j is equal to 2I plus 2 root 3j plus V2. So here V2 bar is equal to what we write here 2 root 3 minus 2 I plus 2 minus 2 root 3 J. So V2 bar is equal to, we rearrange this equation 2 root 3 minus 2 into I. We take minus common. When we take minus common, 2 root 3 minus 2 into J. This is V2 vector. This vector lies in fourth coordinate. Now let us draw the vector diagram. V1 bar is equal to root 3I plus J. This is V1 bar. This is root 3. This is 1. What is the angle here? This is angle root 3I plus J V1 bar. Oh, sorry. Here V1 bar is equal to I plus root 3J. That means here this is 1 and this is root 3. And V2 bar, the magnitude is same. Okay. So this is 2 root 3 minus 2 and this is also 2 root 3 minus 2. 2 root 3 minus 2. So this angle tan theta 1 is equal to root 3 by 1. That is equal to 60 degrees. This is theta 2 and this is theta 1. Tan theta 2 is equal to, magnitude is same, 2 root 3 minus 2 by 2 root 3 minus 2. That is equal to 1. That is equal to 45 degrees. So angle between V1 bar and V2 bar is equal to 60 plus 45. That is equal to 105 degrees. So our option is answer 2. Answer 2. So let us see another question here. Given the masses of various atomic particles, MP is equal to 1.0072 and Mn is equal to 1.0087 AMU, and mass of the electron is equal to 0.000548, and mass of the neutron is equal to 9, mass of the neutron is equal to 2.0141 U, where P is proton, N is neutron, E is electron, mu is antineutrino, and D is deuteron. Which of the following process is allowed by momentum and energy conservation? Momentum and energy conservation. See that first question in first bit, proton disintegrate as a neutron plus positron plus antineutrino. So here mass increases. So this equation is incorrect equation. That means here mass of the products is greater than mass of the reactants. So this equation is incorrect equation. Second one, N plus P gives D plus gamma. Neutron plus proton gives deuteron plus gamma. Yes, here mass decreases. So mass LHS, mass of LHS is greater than mass of RHS, right hand side. So in the second case, here left hand side mass is greater than right hand side. So this equation is correct equation. Whereas in third equation, electron plus positron gives rise gamma. This is incorrect equation. What is the correct equation here? Electron plus positron gives rise to gamma. So kabatti this is incorrect equation. Fourth one, neutron plus neutron gives rise deuteron. Neutron plus neutron gives rise to deuteron. So this is not correct. This is not correct. Neutron plus proton gives us deuteron. So among the following equation, so which one is allowed by moment and energy conservation is neutron plus proton is equal to neutron plus gamma. So our option is option 2. So let us discuss another question here. A charged particle going around in a circle can be considered to be a current loop. A particle of mass m carrying a charge q is moving in a plane with respect to v under the influence of magnetic field B. The magnetic moment of this particle is. So here, moving in a plane with a speed v under the influence of magnetic field. So this is, let us assume that magnetic field is into the paper. Magnetic field is into the paper. So a charged particle enters into the magnetic field with a velocity v. By right hand thumb rule, the force acting on the charged particle is along this direction, so that the charged particle takes a circular path like this. Okay. So m is equal to magnetic moment. This is a current loop. This current loop acts as a magnetic dipole. So magnetic moment is equal to I into A. I into A. So magnetic moment is equal to here. I means Q by T into A. So m is equal to here Q by T means time taken to complete one rotation, that is 2 pi r by v into A. A means pi r square. So magnetic moment is equal to here QV by 2 pi r into pi r square. Pi cancel. So m is equal to what we get here QV by here QVR by 2. But whenever a charged particle takes a circular path in a magnetic field, the radius is equal to, we write mv by qb. mv by qb. So m is equal to, substitute this value in this equation, qv into mv by 2 qb. So qq cancel. Here we get here m into v square by 2b. m into v square by 2b. But here the magnetic moment direction is opposite to the magnetic field. Curl fingers along this direction, then magnetic moment is opposite to the direction of magnetic field. So that can be written as m is equal to, in vector form, so mv square by 2b into minus b cap. So negative direction of magnetic field. So we write here m is equal to, what we write here, m into v square, that is equal to here minus v cap is equal to what, b bar by mod b, that is equal to 2b square. This is the expression for magnetic moment. So minus mv square b bar by 2b square. So our option is, second one is correct option. Second one is correct option. The magnetic moment vector is always opposite to the magnetic field vector. So negative magnetic field vector direction, unit vector direction. So let us discuss another question. A young double slit experiment is performed using monochromatic light of wavelength lambda. The intensity of light at a point on the screen where the path difference is lambda is k units. The intensity of light at a point where the path difference lambda by 6 is given by nk by 12, where n is the integer. The value of n is. We know that here I is equal to intensity of light I is equal to 4a square cos square 5 by 2. So 4a square cos square 5 by 2. We know that phi is equal to 2 pi by lambda into path difference. So phi is equal to 2 pi by lambda into whenever the path difference is lambda, then phi is equal to what we write here 2 pi. Phi is equal to 2 pi and I is equal to what we write here k. Substitute this value in this equation. K is equal to 4a square cos square 5 means 2 pi by 2. Here 2 to cancel. K is equal to 4a square cos square pi. Equation 1. Right. This is case 1. The intensity of light at a point where the path difference is lambda by 6 is given by nk by 12. So in the case of case 2, when intensity becomes nk by 12, so what we write here 4a square cos square. So path difference is equal to how much? Lambda by 6. Lambda by 6 means here phi is equal to 2 pi by lambda into lambda by 6. Lambda cancel. 2 ones are 2 3s are pi by 3. 4a square cos square 5. Cos square 5, that is equal to cos square pi by 6. This is equation 2. Phase difference is pi by 3. Now, here this is equation 2. Now, equation 1 divided by equation 2. K by nk by 12 is equal to cos square pi divided by cos square pi by 6. K cancel. 12 by n is equal to what we write here cos square pi 1 by cos square pi by 6 cos 30 root 3 by 2. Root 3 by 2 means 3 by 4. 3 by 4. So n is equal to what we write here 12 into 3 by 4. So 4 3 is n is equal to here we write 9. So what this is integer type of question. So n is equal to 9. So here next question, the center of mass of the solid hemisphere of radius 8 centimeter is x centimeter from the center of mass of the flat surface. Then the value of x is. So this is hemisphere. This is flat surface. This is the center of the flat surface. And this is radius of hemisphere 8 centimeter. So here this is center of mass of hemisphere. The center of mass of hemisphere is x distance from the center of the flat surface. Now they ask what is x. The center of mass of the hemisphere is x is equal to 3r by 8. Actually, the distance of center of mass of the hemisphere from the flat surface is 3r by 8, that is x. So x is equal to what we write here, 3 into r 8, 8. R is 8 centimeters divided by 8, that is equal to 3 centimeter. This is the answer of this question. So here what is our answer? 3 centimeter.